Broadcasting live from SETI Alpha 6 in the Andromeda Galaxy, this is Mr. C.
Well, happy downhill day to you. Wednesday already. So, hey, I know you've already got a white sheet. You've already numbered 10 on it. So you'll need that white sheet in just a little bit. You've probably got your do nows going already, homeworks going into your lesson planner, and you can see it up on the board. And here's what it is. This Friday, you've got a test, right? It'll be your last test of the quarter. So you want to do well on it. You want to finish strong. If you need points to raise your average, you'll want to do really well on this. So here it is, Wednesday. I'm telling you what's going to be on the test. And the homework for tonight is to triple R LS 2 through 4 plus Psalm 139, 13, and 14. Now, the assignment is review triple R LS 2 through 4, 10 to 15 minutes. Go over all of that a couple of times. Now, take a break after 7 or 8 minutes if you need to. But I'm asking you to triple R up to 15 minutes on LS 2 through 4 plus Psalm 139. Psalm 139, for you formed my inward parts. You knitted me together in my mother's womb. I praise you, for I am fearfully and wonderfully made. Wonderful are your works, and my soul knows that full well, or very well. I'm the wonderful work. I will ask you that on Friday. What's the wonderful work? And you're going to put down me, hopefully, for 1 point. Okay? So anyway, so review that. Back to this test just for a little bit. This is it as far as a big point getter for this quarter. We just have this week, and then next week no tests or quizzes. So anyway, might be a few little assignments, but no tests or quizzes on Friday next week. Okay, now I've got a quick announcement for all of you, and this is just in case I've sent you a Teams message and you haven't seen it. So I sent out a number of messages last week, and I want you to check that you got my message. So in period 1, here are the folks that I messaged: Connor, Landon, and Breck. And then, that's period 1. In period 3, Caleb, message to you. Nate, message to you. Paige, a message to you. And Bram, a message to you. So if you haven't looked at them, look at them. Because it might involve work that still needs to come in. And remember, Friday is the deadline. So get that in. And then period 6, Ray. And then Trevor, Carson, Sean, Amelia, Abe, and Zach, and Uriah, and Jaden, and Elijah. So check those out. Check to see what they were all about. Okay? So that'll be great. Okay. Now, I know you've already reviewed about 3 minutes, LS 2 and 3. So I'd like you to turn over LS 2 and 3. You'll need a red pen for this. Is this a pop quiz? No, it's not. But we are going to grade it. And once we do, if you get a 9 or a 9.5 or a 10, you can turn it in for a score. I'll put it in the computer. And it ought to help your average. So it's just review. I'm going to go do it really quick. So anyhow, now I see on here I'm rewinding. I didn't think to tell you again about the meaning of Psalm 139, 13, and 14. What does Psalm 139, 13, and 14 mean? I'll ask you. It will be on the test Friday. It means God designed me. That's what it means. God gave me my genes. Or God gave me my DNA that make me look like I am and have the personality that I have. So one more time, instant replay, what's on the test on Friday. Lesson summary 2, 3, and 4. All of that information. I'm reviewing some of it today. Psalm 139, 13, and 14. You'll have to write it. It'll be worth at least 2 points. So maybe 4. So make sure you know it. Some of you still have got to dial it in yet. And then the meaning, God designed me, for Psalm 139, 13, and 14. Okay, you've numbered 1 to 10 on your white sheet. So here you go. You can't use your lesson summaries to get the answers off the top of your head. Use your cover sheet. Use that other sheet. Doesn't count unless you want it to. All right, number 1, what is a push or a pull in science? It's number 1. What's a push or pull? Write your answer fast. We're not going to have a lot of time for this. 2, what do you call the spinning motion that an object like the moon, the earth, or the sun do? They spin on their axis. What's the name for that? Number 2. Write it quickly. Number 3, what do we call the motion of one object around another, held in by the gravity of the larger object? What's that called? Number 3. The motion around another object. Number 3. Number 4, what are the 2 reasons for the season? My goodness, we've had that so many times. If you miss that, I'm shaking my head. Number 4, 2 causes for the seasons. 4A, 4B. Number 5, what do we call spring and fall? They have a name. It means equal day. So what is it? The 2 seasons, spring and fall. What are they? That was 5. Number 6, what do we call the 2 seasons in the northern hemisphere? Tilted toward the sun, 6 months later, tilted away. Tilted toward, tilted away. What season? Number 6. Number 7, how much matter an object has? What do we call that? There's a name for it. Amount of matter something has. Number 7. Amount of matter. Number 8, how hard you're pulled by an object, like on Earth. How hard you're pulled would be your, how hard you're pulled on Earth, what is that called? That's your what? So number 8. Number 9, what is the name for the force of attraction that an object has for every other object in the universe? What's that called? What is the force of attraction? How hard objects pull on each other and every other object in the universe. What do we call that? The attraction force. And then number 10, there's a law about that. And who's responsible for that law? He said every object in the universe attracts every other object. It's a law, a scientific law. A law is a concept that always works out so that you can always count on it being right. I want to know who the person was who came up with that law. Was it Galileo, Newton, or Hooke? Just the last name's fine. Galileo, Galilei, Isaac Newton, Robert Hooke. Who was it? Multiple choice. All right, red pen. We went over it quickly. It doesn't count. Only if you want it to, then you'll pass it in with your name, date, and period in the upper right-hand corner. Okay, here are your answers. Okay. Number 1, a push or pull. That's a force. Got to be force. There isn't any other answer. Number 2, spinning around. Rotation. Rotation. That's why I had you rotate. Okay? So rotation. Number 3, going around another object. Revolution. 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 Number 3, revolution. Number 4, the 2 causes of the seasons. Tilt of the earth and the revolution of the earth around the sun. Half each. Tilt, revolution. Number 5, spring and fall. The equinox. You didn't have to sound it exact or spell it exactly right. Sound it out. Equinox. Equinox. I told you it means equal night. What do we call the tilted toward in the northern hemisphere, or 6 months later tilted away? Summer solstice, winter solstice. So number 6, solstice. Number 7, the amount of matter that an object has. What is that called? Mass. That's the mass that an object has. Number 8, how hard an object's pulled on Earth or anywhere. You'd obviously be pulled harder on Jupiter or the sun if you could actually go to those places, which you cannot. So what is that called, how hard you're pulled? That would be your weight. There isn't any other answer. Number 8, weight. Number 9, what's the force of attraction that every object in the universe has for every other object? It's a law. What do you call it? It's called gravity or gravitation. The universal law of gravitation or gravity. Either one. Who came up with that law? Who mathematically proved that it existed? It's Isaac Newton. Isaac Newton's universal law of gravitation. Isaac Newton. Okay? So, here's what you've got to do. Just put the number right. You had over 10 at the top. If you had an 8.5, a 9, or a 9.5, or 10, you probably want to count it. Probably would help your average. So pass it in to the center. Mr. Gilbert will pick those up. All of you that want that to be counted. Okay, it's time for a question break with Mr. Gilbert. So if any of you have any questions so far, raise your hand. He'll stop the video and answer your questions. So go for it. Okay, I'm back after that little question time out. So there are a few things on LS3 that I wanted to go over. So if you'll have LS3 out and get ready to highlight a little bit LS3. LS3. I'm going to tell you one more time what terms you need to know. So I'd red dot them if I were you. You've got your red pen out. Okay. I've already asked a number of these on this, on that little, I'll call it a review quiz. Okay? All right. So get ready to dot. These are things you've got to know. These are things you're going to study tonight. Force, push or pull, gravity, all objects attract each other, Sir Isaac Newton, his universal law of gravitation or law of universal gravitation. Red dot by that. Study it. And then highlight this. The strength of the force of gravity between objects depends on how much mass the object has and then how far away they are or close they are to each other. Closer, stronger pull. More mass, stronger pull. So those two things are right there. So highlight them. There's mass right there. Highlight it. Mass right there. The amount of matter an object has. Your weight right up there. Weight right there. Highlight it. Red dot it. Study it. And then down below, a few things. Down below, inertia. Here's what inertia is. I have a baseball right here. Inertia is how hard it is to get an object moving, or once an object's moving, to stop it. Inertia is the resistance to either starting to move or getting an object that's moving to stop. That's inertia. And you see it right down there, red dotted, the tendency of an object to resist change, or to resist moving, or once it's moving, to resist stopping. Now, the more mass an object has and the more velocity it has, the harder it is to stop. Okay? Now, a baseball doesn't have a lot of mass. So, is it relatively easy to stop? Yeah. With a baseball glove or a baseball bat, to change the direction, or hitting a fence, or being caught by a fan, it stops the motion. Okay? So, not a lot of mass, not a lot of inertia. And notice, red dot this, the more mass that an object has, the greater its inertia. So it's harder to stop or start an object that has more mass. So in the solar system, what's the object that would be the hardest to stop, that has the most mass? The sun, of course. The sun. And it's traveling really fast. It's got a lot of mass and a lot of velocity. So, and then over on the right side, Newton's first law of motion. Here's what it is. That and just one other thing. So here it is. Newton said this. He said, and this is called his first law of motion, or Newton's law of inertia. Okay, and here's what he said. So he said that an object that's not moving will continue not to move. So it's not moving. It will continue not to move unless it's acted upon by a force. I pulled it. Remember, a force is a push or pull. So I could push it, and then it moves. So there it is, his first law of motion. An object that's not moving tends to continue not to move unless it's pushed or pulled. That's Newton's first law of motion. Or he said this, once an object is moving, an object will continue to move in a straight line at the same speed unless acted upon by a push or pull. Now, as I'm pushing it toward the camera, Newton said it would continue to move in a straight line at the same velocity. Now, that would be in a vacuum. There's air here that will slow it down, and if it hit the camera, it would probably stop, but the camera's going to move a little bit and maybe be damaged. So that's Newton's first law of motion. An object at rest will stay at rest or not move unless it's acted upon by a force, a push or a pull, or if it's moving, it'll continue to move unless it's acted upon by a push or pull. How will it move? In a straight line at the same velocity is what he said. And then the last thing on LS3 to put a red dot by is right here. Newton said this, that the inertia right down there, see where it's dark, right there. Put a red dot right there, just like I did. Okay? He said that inertia and gravity continue to keep Earth in orbit around the sun. Its inertia, its tendency to keep moving at the same speed in the same direction, and also the gravity of the sun. Okay? Those two things keep the Earth moving in orbit. So review all of those things. So make sure you review them. Then I wanted to show you this. I wanted to show you one more time from LS4. If you have LS4 in front of you, you might want to red dot some of the things in LS4. First, the phases of the moon. The phases of the moon. Mr. C, you should have kept LS4 in front of you. I know I should have. So, phases of the moon. It's the different positions of the moon as it revolves around the Earth. There were 8 phases that I want you to know. Now, you could now, or tonight, if you hurried up, you could make this little diagram of each of the different positions of the Earth. If you don't do it today, we'll do it tomorrow in class. Here are the 8 phases of the moon. When it's right here and we're on the Earth looking back at the moon, we just see a darkened disk. It's dark. That's new moon right there. New moon. And then over here, as it moves this way, it wouldn't move that fast, but as it moves this way, in this position right here, do you remember the terms waxing, 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 getting bigger, waning, 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 waning. Waxing, waning. So the lit up part of the moon is getting bigger. So it's waxing. This is a waxing crescent right there. And then it's 1/4 of the way around. So that's first quarter moon. And then over here, it's still waxing. A waxing gibbous, G-I-B-O-U-S, weird name. And then it's fully lit up right here in this position, right there, opposite the sun, fully lit up, obviously, full moon. And now it's getting smaller as far as how much is lit up. So it's waning, isn't it? A waning gibbous, 3/4 the way around, third quarter, right there, third quarter. And then right here it's continuing to wane, a waning crescent, and back to new moon. About a 29-day sequence as it goes through the phases. Here they are again. See if you can say them as I move them. For starters, it's dark when we look at it from Earth. New moon. Now it's waxing, so it's a waxing crescent. 1/4 the way around, first quarter. It's still waxing, a waxing gibbous. Fully lit up now, right here, full moon. Now it's waning, a waning crescent in that position. 3/4 the way around, right there. What is it? So it's 1/4, 2/4, 3/4, third quarter moon there. And then it's still waning, a waning crescent, and a new moon. Okay? So tomorrow I'll have you draw those if you don't do that on your own tonight. You don't have to. Okay? And then there are the eclipses that I want you to know about. You don't have to know umbra and penumbra. You don't have to know that as far as the eclipses. But I do want you to know that eclipse means light is cut off. So light from the sun is cut off to an object. That's called an eclipse. Light is cut off. Okay, now in this case the moon is in the way, blocking sunlight so it can't reach the earth in a small section of the earth, the shadow of the moon. This is a solar eclipse, because if we're in that shadow, the sun is blocked. And in rare instances, the sun is totally blocked. A total solar eclipse. I think the next one going across the United States is in 2000, I want to say 4, but I'm not sure. I hear it is amazing to see a total solar eclipse. It's just incredible. My brother-in-law has seen one. we're talking about going to Texas, the Waco area in 2004, to see the next total eclipse in the United States. So we'll see if we get to do that or not. It would be oh so cool. So again, the moon is in this position. It's really the new moon position. This is also called a solar eclipse. Now over on this side, when the Earth gets in the way, blocking sunlight to the moon. So the moon now, light is cut off to the moon. This is a lunar eclipse. Lunar, Latin for the moon. Solar, Latin for the sun. Okay? So lunar eclipse, solar eclipse. Okay? So there you go. Okay. Now, I've got a little, just short video about Isaac Newton that I want you to see, and in your journal, I'd like you to just jot down a few bullet facts about Isaac Newton's life. Then you're going to work on your homework. I'd like you to review LS 2 through 4 for about 15 minutes. Okay, you're already reviewing for the test on Friday, not tomorrow, on Friday. Tomorrow we'll consider eclipses again. I'll have a video for you on eclipses that I think you'll find really cool, and maybe a video also on the phases of the moon. So, Mr. Gilbert's going to start the Isaac Newton video, and then you'll have a little bit of opportunity to review LS2, 3, and 4. See you on Thursday. Hard to believe it is almost close to the end of the week.